Hello everyone. In this video, I will provide a brief Hello everyone. In this video, I will describe the types of data and also go over the typology and measurement levels that are available in SPSS. To begin with, in statistics, the types of data are categorized into two parts, the qualitative or categorical data and the quantitative or numeric data. The qualitative or categorical data or description of traits, any data that have categorical nature, such as color, type of car, name of cities, etc. I don't necessarily say that a qualitative data is a non-numerical data because sometimes we do have qualitative data that are numbers, but rather than describing a measurement, those numbers actually describe a trait or provide description of an object. So the quantitative data, as the name defines, are numerical data. They are either counts or measures. For example, age of someone, salary, amounts, height, etc. So the quantitative data are uh, divided into two parts. There's the continuous data and there's this discrete data. Generally, continuous data are measurements that can take on any value. For example, height of a person. A person could be 6.5 feet, or a person could be 6.2 feet, or GPA. Somebody's GPA could be 2.79 base, which I hope that never happens to anybody. 2.79 is not a bad GPA. 1.9, 1.95 GPA is probably the example I should have used. Or GDP or any sort of any kind of measurement or values that could be measured are pretty much categorized or defined as continuous data. On the other hand, we have discrete data, which are counts. They can be measured, but they can be counted. We won't have decimal points when we explain them. When we can't say 1.5 cars, or we can't say 1.2 apples, or we'll say 2.5 trucks. So these are counts. These are discrete. So number of cars, persons, apple, a person has breakfast for apple, a number of apples a person has for breakfast every morning, etc. So these the type of data overall in the discipline or knowledge of data and how they're categorized into two parts is now explained. Let's go to types of scales or levels of measurement that are generally described in the textbooks and also used in applied statistical and data analysis. Um, the first one is the nominal data, which are categorical scales or nominal scales, such as classifications, labels, and etc. And so nominal data or nominal scales kind of ties back to discrete data, where our data could be names or labels or countings, etc., such as name of a country or name of a person or classes or anything that has categorical essence to it. The second was the ordinal data. Ordinal data have order to them. For example, first, second, high, medium, low. As you can see, these are nominals, high, medium. These are nouns or these are words, but they have ordinal scale to them. So high and medium, what is the difference between high and medium? It's that high is higher than medium. There is an order to them. Or first and second. Number one is a numerical data, is a quantitative data. But if we use it in the context of orders, one and two are different, not only in terms of difference in numbers, but also difference in their order. So that's the ordinal data. And then we have a ratio, which is the most common quantitative scale that actually has meaningful differences. Not only that, but it's also important to understand because this is one of the major indicators of difference between a ratio and interval is that in ratio, we actually there's actually zero indicates the absence of the quantity that's being measured. For example, we cannot say um, this and this person is 0 years old. The moment we say zero, we're actually indicating that object or that person does not exist. So zero is indicator of absence. So in ratio, example of ratio data again could be, or ratio level of measurement could be someone's age. If someone is 0 years old, that means that person does not exist. Or if we say someone is paid $0, that means that person was not paid at all. So zero is not a number, is not a data. It does not signify or indicate anything. On the other hand, we have interval data or interval level of measurement or interval scale, which is a quantitative scale in which zero does not indicate the absence of the quantity is being measured. It means that it it actually indicates the presence of the quantity of something that's being measured. For example, if we say 0 Fahrenheit, it does not mean that there is no temperature. It just means that the scale of 0 Fahrenheit identifies something that if we convert it to Celsius, then it's a different number. Some zero in Fahrenheit is a different number in Celsius. So zero actually indicates the presence of something, unlike ratio. I hope this was helpful. Let's go to types of skills and data in SPSS. Um, these are general concepts of data and skills that are generally described in the realm of data science and statistical science and data analysis. But let's look at the tool to see how actually the tools communicate with these levels of measurement and the data that they come with. In this case, I'll use SPSS. SPSS, this is the variable view, and this is the data view. These are the two views that are important to know while using SPSS. Unlike Excel, SPSS has two faces to it. There's a data view where you view and do your input, where you view the data and input your data. And variable view is where you actually program the design of your data. So let's say we would like to build four different variables or five different variables. And in the context of data and data types, it's very important to know what a variable is. A variable is pretty much any characteristic or number, quantity, anything that can be measured or can be counted, and they can take on any value. For example, if we say number of pens and we put 2 pens, the 2 pens is a variable. Or if we say age, the age could take on any value, and it's used to measure something, which is or height or age in years is something that measures someone a age of someone or how old someone is. Or let's say height. Height is also variable, and let's say if we use feet to measure height, then uh, we are quantifying or we are measuring or counting a characteristic of an object. So that characterization is actually something that we say, is the end product is a variable through which we develop a variable. And the age and the height and all and the variables have the um, have the common characteristics of the taking different value. So someone could be 6 feet and then someone else could be 10 feet. So let's start with the first one. I'm going to start with the name, and as soon as I put the name, as you can see, the rest of the cells populate. Um, these are the measures that I just explained that SPSS knows. All other sub measures or subcategories or uh, scales are actually fall under these three. Scale, which is any numeric value including ratio, interval, uh, integers, anything that has numerical found nature to it actually falls under a scale. Ordinal is, as I just explained, is any data that has order to it, and nominal is any categorical data uh, that I just explained. So the first one is a name, so I would choose nominal. And let's say the second one will be age, and we're looking at the second variable, age, and I will choose scale since we are looking at number data. And the third one is, let's say, gender. And since it's gender, we're going to select nominal again. And the last one we say level of education. Remember, SPSS is very sensitive to labeling. You can't have a label name with spaces on them, such as something with a space. It's not going to accept it. It's not the right naming convention to use. So if you want to have that, you'll have to use the fillers, such as the underscore here. So the level education will be ordinal because we will have different levels of education starting from the highest to the bottom. Some other stuff that I need to describe here are the type of data besides the levels of measurement. The name will be a string here. Although we selected nominal, it's also good to select string. And a string or in R, and they have different names in different programming tools. Sometimes they're called character data, string data, text data, depending on what tool or uh, platform you use. So string is the name that SPSS uses for character or categorical data. So we'll use string for the name. For the age, we will use numeric values. Do we need decimal places? At decimal places, we don't because somebody could be either 1 year old or 2 years old. Someone can be 2.5 years old. In this case, we just put zero decimal. So this will not take any decimals. And we will select numeric. And gender is going to be uh, string as well. Apparently, uh, SPSS does not have logical variable types where we can put true or false or male or female, but we can select string for this as well. And then level of education can also be string. So the width, especially for the character for the string type of variables, designates the number of indexes that are allowed to be typed into a variable. For example, if we select 2 and go to data view and we put, let's say, XYZ, it does not allow the Z because we have already selected the width to be 2 indexes. So the common is 8 for all of them. Unless, for example, level education, maybe this could be 10 or 12 because we have long index of wording index for education level. If somebody's post uh, PhD and has and with additional academic labels, and I would suggest to add more with decimals. As I just explained, we don't need decimals for age, for gender as well. They do not apply to here. Label, and this is very important because, like here, sometimes we don't explain the name of the variable enough on the actual data view. So the label allows us to provide explanation of what it is. For example, and the label also allows us to have space and special characters. For example, level of education, we can say level of education surveyed. So as you can see, it allows. So if you put an acronym here, for example, like lev and then ed, or if you can just put led, you can actually label describe the label here. And the good thing is when you run a test on your variable, you're going to get the results based on the label rather than the name. And values, I'll have a separate version video on the values, but sometime in the surveys we don't actually write, for example, we don't actually write the actual name of something. We instead we write the numbers, that the attributes of the values. For example, in the case of male or female, we can actually, if we have a series of data for one for male and two for female, then if our survey has captured the data um, through numerical attribution, then we can actually change that attribution here through values and say if it's 1, then it should be male, and if it is 2, then it should be female, and bingo. So once you go back to data view and you click on this here, 1 second, male, and especially if you will have to change this to numeric. Yeah, so when you go, I'll have to put some names here. This must be, yeah, this is numeric as well. Yes, I should have put the values for, I should have put the values for gender, not for here. So let me go back and change this here. Change this back to string because names are string. Let's go to gender and um, change this to numeric values here, and then allow it to have values for each of labels for each of the numeric numbers there. So 1 will be male and 2 will be female. And then when you go to data view, when you click on the switching between names and the value labels, you should be able to see them. So again, in surveys, most likely you won't write down male or female or actually the complete attributes in alphabets. Rather, you just put 1 or 2, 3. You use numbers more than anything else. And it's also easy for the machines to be able to read those rather than read the alphabets. So this is the use of values. Missing is in case we have any discrete missing values, or if if we have a scale continuous data, then this will be activated and we'll have to select based on it. For example, in this case of scale, we're going to have this activated. So if we have any missing values, then null values, then we can add them here so that it can disregard them. And the column width is nothing but the width of the column. So for example, we just changed the age to 15. You should be able to see it here. It's bigger now. And alignment is the alignment of where the value should be, left, right, center, and the measures I just explained. And the role for right now, we just put them as input because we're going to input information. The partition splits and the other features here, I'll explain them in other videos. But there you go. We just created our first data set with 4 different variables. So let's say this person is XYZ and oops, name is string. Yep. This person is okay. It's still thinking that it is not a. It happens a lot, especially when you change the data, the variable type in SPSS. It can sometimes retains the previous data type, just like the case here. It still thinks that it's a numeric data, and every time I'm typing, it's not accepting it. Let's see. All right. All right. So I can actually clear that and add a new the variable again. It will be a string, and all the information is there. Okay, great. So now let's go here and move it over here. So XYZ, and the age is 33, male. Level of education is, let's say, PhD. And we have XXX, 26, male, level is it BA, and ZZZ, 22 years old, female, level of education is MA. And we can code the ordinal data just like we coded the gender to go from for one to be male and to be female. We can also code the orders of the degrees so that while we do analysis of orders or ordinal based analysis, the machine can easily read the orders rather than read the text, which will not help in analysis. Anyways, this was it for this video. I hope that it was helpful, and I'm looking forward to producing additional videos on uh, statistical analysis using SPSS. Thank you so much.